Well, welcome everybody. Hope you had a good time at the conference. Great. There was lots of great sessions. I really liked them. So, um, and what we were hoping to do, we wanted to just kind of, I call it a play shop instead of a workshop. That was something that I got from RoboRave, right? From the gentleman who runs RoboRave, he insisted that we call things play shops, right? So it's a lot more, it's about having fun with these things. And for me, the Raspberry Pi is a lot of about having fun, but at the same time, there's serious learning going on as well. So there's lots of opportunities to learn all kinds of really fun things. So um, what I wanted to do today is, I don't have it. Is there a chat? Why am I missing the chat? There's the chat. Let me bring the chat up so I can show it. I'm going to put on the second screen. So I'll do a lot of the whole looking to the left-hand side of the screen to check the chat. Yeah, I really like that background. It's really fun. Right? It's just, I don't know. This is really nice. Yeah, don't worry about your cameras or anything like that. If you have questions, obviously you can do chat. If you want to unmute and interrupt me at a break as we go, I tend to just keep talking. Yeah, so you don't have to. It definitely is a hair thing. I had to go get a haircut yesterday because it was a little raggedy. But so anyways, what I wanted to do today, and I'm gonna go ahead and just make this big. So if you want to see that this web page here is on my IT instructor, and then there's a WASTC link here that I've created. And if you click on that, it's actually going to be from my presentation earlier. So from a Raspberry Pi standpoint, I wanted to just show you all of the resources that I alluded to in the 25 minutes. So I sent everybody home with 3 hours worth of homework. And then my presentation is there. So if you want access to those things, it's just go to the My IT Instructor webpage. It's on the WASTC link up here. And then there's another link also from those that were, if you were interactive on the teaching tips and learning. As we went through, I went and actually recorded all of the links. And anytime somebody mentioned something, I tried to find a link related to it. So tons of good stuff. I use my website to provide resources for my students and fellow instructors. So I want you to be aware that all this stuff is there. So go knock yourself out, have some fun with that. This presentation, there's really not a presentation, but there are some notes here under the Raspberry Play Shop. So if you have a Raspberry Pi, you're welcome to get it fired up and running. If you don't and you just want to hang out with us, that's perfectly fine too. I know this is I do these kind of labs with my students all the time, and I kind of walk them through things. I just wanted to, just this one what I chose was something where we're not doing anything physical as far as you didn't have to have a breadboard and LED lights and things like that. What we're going to do is this really cool health dashboard. So we're actually going to pull information about the processors and the data and the network connectivity on your Raspberry Pi and post it on an internet-based dashboard. So I thought that would be fun. We don't need to have anything extra to do that. So that's why I chose that. So just in case, right? I wasn't sure. And, and I couldn't, I think somebody mentioned earlier, we couldn't Uber deliver, Raspberry Pis to all the participants, which would totally be awesome. But we couldn't do that. So I thought we would do this one. This would be kind of fun. It's pretty straightforward. So what we're going to use is this. There's an online service called Initial State. And as an instructor with a .edu account, you can get a student account that doesn't cost anything, which is totally cool. And so we're going to do that today. So you're going to get that. And then the other thing is I've had some students use these in my IoT course, and they've used Initial State, or they've used Cayenne, or they've used, we played with another one earlier. I even wrote a note down on it. So Initial State, Cloud for RPI. There's different ways of connecting the Raspberry Pi, but in this case, we're going to connect the Raspberry Pi, collect some information from the Raspberry Pi, and have it posted on a dashboard. But you can see down here, like you can connect with Python, REST. If you have this, I think Samsung Smart Things, if you run an Arduino that has network connectivity, if you're doing some Node-RED stuff, Node.js, you can connect different devices, not just Raspberry Pis, to this service, and you can kind of you can trigger events and things like that. So I thought this would be a fun way to just kind of explore kind of some basic IoT things with a Raspberry Pi. All right. So what we need today basically is, if you're going to do this with me, you need a Raspberry Pi, your power supply, SD card. I have the Raspberry Pi OS up and running. Right. So monitor, keyboard, and mouse, or if you're using VNC or SSH, that works fine too. And an internet connection, right? So just a basic Raspberry Pi connected to the internet. You will need to create an account, which we'll do right down here. So I'm using a PyTop Seed, so I've got a monitor and a mouse. I can see my screen off to the left, just in case I ever run into problems, right? So that's more from a teaching perspective. I like to have the monitor available so that, and I can actually kind of show you what I'm talking. Well, you can't see it because I have my background on. Never mind. But I have that off to the side. All right. So step one in this is just going to be to go out and actually register an account. And I believe I already set one up. So let me just sign into a regular account here. So. And I tried to do this where I didn't prep anything. I've done the lab, 5 times, but I didn't prep anything so that you would see the entire process. I did it wrong. That's awesome. Hold on. Oh, that's great. So let's register a new account. It shouldn't like this one. That one shouldn't work. Let's just use my personal account. So if you're doing this along with me, you'll be doing the same kind of thing. All right, so because I'm not using a .edu account, I think it's like a trial period. So we'll be okay. All right, so that's just going to set up my account. So that's about as hard as it gets to set up the account here. We're not going to do anything else. We're not going to set up two-factor or anything like that. We will come back to this in a little while. But in order to go forward, you'll need an account for this. Okay. Second piece is, and we're going to just start grabbing the instructions here. We need to get some stuff done on the Raspberry Pi. So we've registered our account up here. Let me see if I can make that a little bit bigger for you. All right, so we've registered the account. So then right here, this is stuff that we need to do on the Raspberry Pi. So on your Raspberry Pi, you'll need to have a terminal session. So I'm going to use PuTTY for this today. All right, so then I'll get logged into my Raspberry Pi. Okay, and isn't there a way to make that bigger? I always forget that I need to make the wording bigger, and I forget how to do it. This is my SSH terminal session to Raspberry Pi. So I'm running a terminal on the Raspberry Pi across the network. I can show you, let's do this too, so you can see what's going on. So using VNC, which is built into the Raspberry Pi, this is the actual desktop on my Raspberry Pi. So what I'm doing here is really no different than if I was sitting at the GUI and I opened up a terminal session on the GUI, right? So this is a terminal session, and this is a terminal session. Okay, so just running in this case bash. Okay, if you have a Raspberry Pi and you've never set up SSH or VNC, it's really super simple. You go to the menu, you go to Preferences, you go to Raspberry Pi Configuration, and on Raspberry Pi Configuration, you would click on Interfaces, and right here you see SSH and VNC. You would simply enable those two. VNC, when it's enabled, you see the VNC logo up here. SSH is, you just won't see anything for SSH. If you don't have access to the GUI and you do have access to SSH, you can also run raspi-config. Oh, I got to run it with sudo. And you'll have a graphical version of the, or I'm sorry, a menu-based version of what we just did. So interface options, and then you can see, you can go to SSH and you can enable or disable, and you go to VNC and you can enable or disable. Okay. I'm just going to exit out and broke it so that I don't change any settings. But there's just two different ways to do that. To get those settings set up, and then you would just log in with whatever you have set as your username and password. Okay, so I'm going to minimize the graphical interface so that it doesn't get in our way today, and we're going to run some of these commands. So they just want us to. Oh, I should have thought about that. This thing is always going to disappear on me every time. So I right mouse click and copied over here, and when you right mouse click in the terminal or a bash, it will actually post whatever you copied. So this is going to hit enter. So that's just going to change our home directory. We should have already been in the home directory. And then we're going to grab some stuff from initial state, right? So we'll use the curl command here to do that. It's one of the nice things about a lot of the tutorials is they've provided you the commands, and for your students you can go through and kind of explain each one, and we could actually have them look up curl and then look up what all these different arguments are and things like that. But because of timing, we're not going to dig into it overly too much at this point. So this is going to do a real straightforward installation. It's installing some setup tools for Python. It's going to set up this thing called an IS streamer, which will allow us to connect to the initial state service. It also, I think it double checks to make sure you have pip installed, because we need to do pip installation here in a minute. All right. There is also instructions here if you're getting a pip error. If you're using the latest version of Raspbian, or sorry, not Raspbian, it's Raspberry Pi OS now. If you're using that latest version, pip is already a part of that. But if you need to install pip, there's some instructions here on how to install pip, which is a packet manager for Linux. All right. And then step 3, which is real simple. Step 3, right down here where it says, do you want to automatically get an example script? We're just going to say yes. And we're going to hit enter. And it's going to ask us, where do you want it? In this case, we're going to put it in the root directory, I believe it looks like. And we're just going to leave it as isexample.py, which is a Python program that was pre-run for us. And then the next step, which you can see, I'm going to scroll over here because this is a little bit bigger. So what you're seeing right here and right here are the same. So we're using, this is new. It tells you right here if you're using, actually tells you right down here, if you're using, if you're new to this and you're not using an older app that you've ever done, you're just going to use number 2, which is going to allow you to log in with a username and password. So we're going to hit number 2 here, which will then ask us for the email and password that we set up on our account that we did earlier. So this is the account I was talking about here. So that's the one we set up earlier. So I need to put in the password or the the email that I used, and the password that I use. And then it says getting Python example scripts, and all done. All right. So now what I've done is I've installed the software that I need to connect to initial state, and I've logged in to initial state, and I've downloaded a Python program, which we'll open up here in a second to check out what that's all about. Okay. So then at this point, they want us to, we want to open up this file in Nano. Okay, so Nano is just a text editor that's built into the Raspberry Pi. And so what we're going to do there is just open up this file. So this is the file they gave us, is_example. So it's loading up from isstreamer .streamer. It's loading the streamer components that we need. We're importing time so that we can, right down here, put a pause in our system or in our program. And then right here, streamer equals streamer. And this is what they want us to look at is in order for me to access my particular account, and because I used my login, it grabbed this information. So this information right here, which I will change as soon as this session is over, is a access key for my account to connect to my initial state and send up, to stream information. So what this example, what this key or this program is going to do is it should create a connection to initial state, and it's going to post some information. And we'll take a look at that information in a minute. But they want you to kind of, and this is good for students too, is we want them to understand that in most cases when they're connecting to some kind of online service, there's going to be access keys, there's going to be tokens, there's going to be secrets, there's going to be some, like Twitter, we use 4 different numbers to connect to the Twitter streamers and things like that. In this case, we're using a single system generated token, right? This access key here. Okay, I'm just going to go ahead and hit Control X to drop out of that program. And then let's go back to, I need to close these these ones here because they're not helping me. So here's my account. If I go to home, all right, so right over here is where I would have any kind of connected apps to my system, right? And way up here, it's where I got to move my my accounts over here, right? And the one thing that the instructions were asking us to do is to go to my settings, and what you would have seen is that this key code right here should have been the same key code that they embedded into that program. All right. So I'm going to go back over here, and what I want to do is on my Raspberry Pi, I want to run this program, this is_example. So to run that, we were just going to run it as Python, right? is_example.py. And it should run, and it returns back to a prompt, right? So this program has an endpoint to it, so it ran and finished. And what I'm hoping that I see here is when I refresh, I should see now we have Python stream example. So when I click on that, what my program did was it produced these different dashboard components. So my messages, my numbers, my booleans, and my events. Okay. So how did we get those things? Well, let's take a look real fast so we understand a little bit what's going on here. So here's the code. And right here, streamer.log, right? My messages, stream starting. So when we started this program, or when we got to this point right here, we connected to initial state with this line. And then this next line here created this box called my messages, right? And it would have said stream starting, okay? This currently says stream done, and I'll show you why that is in a minute. But the very first thing it did, it says stream starting. And then for num in range 1 to 20, so we're going to start with number 1 and we're going to count up to 19. And that's going to be a loop, right? So it's going to be a counted loop. And then once the loop is done, it'll drop out of the loop and do this last executable command down here. But while it's in the loop, it'll pause for 0.1 seconds, and then it will create a new log called my numbers, which is this log right here. And then it's going to ask, it's actually going to post the number, which is going to be 1, 2, 3, 4. Each time it goes through, it'll post a new number. Okay. And then it's going to take that number and divide it by 2. And if that number is 0, it will create a new log called my booleans, and it will put the word false in there. And then if it's not divisible by 0, then it would place the word true in here. Okay. And the end state of this was the last number, which would have been 19, right? So actually it shows 19 there, but it should have been a graph number 9. There it is, 19. Okay, so 19 divided by 2 is not 0, so then it should have left true, which is where true came from. Also, there's an if statement here for num divided by 3 equals 0. So the very first time it got to 3 and divided itself and it was 0, actually that's 1. So when num is not equal to 0, it would have automatically populated this event called my events with the word pop. Okay. And then the last one here, if num divided by 10 is equal to 0, then we're halfway done. Okay. So that way, this one should have said stream starting, and then halfway through it should have said stream done. We didn't get our stream half done, and then after it's finished with the loop, it would have dropped out and pressed stream done. Okay, so this little program, real simple, just kind of to show that we can connect and make a real simple connection. It counted up, and then what's neat about these numbers here is I can right mouse click on the tile, I can edit the tile, and I could change it to a straight line. I can change, we can do, there's all kinds of different points, like we can change it to point style and then straight line, and it would actually change. You can see that it's going to change the actual number, right? So now that graph changed. So you can adjust how the graphs look, which we'll show you in the next step. Okay, so this is just a simple example to make sure that you can connect to initial state, and you've sent some data from the Raspberry Pi up to the service. Okay, now for what we really want to do, right? Because all of that's just getting ready. What we want to do is I'm going to move on to part 2, and with part 2, we need to install the PSUtil, which will allow us to gather data from the Raspberry Pi. So this is a Linux command or a Linux utility that allows us to connect, or Python utility allows us to connect to the system information, right? So we're going to do sudo pip install of psutil. So we'll let that run. It doesn't take very long. And I looked in the chat, I'm not seeing. So while this is installed, I'm taking a look. Is there a way to do this with VM? So you're trying to run this in virtual or on a, are you trying to think about, I'm trying to wonder this question here, right? Are we, and it's Julio that left. Okay, so VM, are we trying to run Raspberry, the OS in a VM and connect to the Raspberry Pis? Because if that's the case, we've done the Raspberry desktop on a VMware ESXi system. If that's what you're trying to do, or if that's what you're asking. trying to make sure I don't miss anything there. All right, so that's done, that little install. So, right, so we installed the PSUtils. That's going to allow us to gather data about the processors, the amount of RAM, the hard drives, the network interface. And then we need to do a little bit of command line things. We're going to make sure that we're back in the home directory. Okay, so home directory. Yes, this is being recorded, which is nice. So then you can kind of go back and walk through each of these pieces. And then we're going to make a directory called Pi Health. So what we're trying to do now is we're going to create the components that we need to gather up this the health status of our Raspberry. And then we're going to change our directories over to the Pi Health directory. Okay, so you can see there, man, it's hard for me to see, so I know you guys are having a hard time. So we're in the Pi Health directory, and if I ls, there's nothing in this directory. Okay, so the next piece, I'm going to move that off to the side. The next piece is the part that it's not overly complicated, but it acts funny. Well, at least my Nano on PuTTY acts funny. So what we want to do is the person who's created this, or actually Initial State, who created this tutorial, they have given us the pihealth.py program as part of their GitHub, and we're going to go copy that into or onto our Raspberry Pi, and then we need to make a couple of changes to the file itself. So what we want to do first is we're going to go to this link here, which is going to be this really long program, and this is, they wrote this program as the dashboard. And one thing I like about this is, like, we can, for us right now, we can do this and have the dashboard done. And then with my students, we could kind of dig into what's actually going on and what's happening there. So I'm going to copy this. So I'm going to just right mouse click and copy. And then on my Raspberry Pi, I need to open up a new program called pihealth.py. So I'm going to do nano, right, which is the editor, and then pihealth.py. And what that's going to do is it's going to create the file pihealth. Well, as soon as I save it, it creates the file for me. But pihealth.py. So now I'm in the editor, and in the editor, I'm going to right mouse click, and it immediately copied everything that I had done, that we had copied from over before. So, and now one of the kind of the funky things about Nano, if you've ever played with this, is you got to use the key, you got to use the up arrows to do this, right? So all the way to the top of the file, this is the top of the file. Right here, remember that access key that we pointed out earlier? What we need to do is we need to go to our account, and we need to copy that, and we need to put that into the program right here, where it says put your initial access key here. So I'm going to get rid of the key. I'm going to go back to my initial state system here, and I'm going to go to my settings. And I'm going to copy my key code. You can try to type it in. Sometimes Q's, well, that's a Q and that's a G. So, but I think the easiest thing to do is copy. So I'm going to go back here, and right where I'm at, I'm going to right mouse click, and it should put in my code. You see that it put my code in right there. And then you can see that my quote is on the wrong place. So I'm going to backspace once, and now my access key has been, it turned green. So it's showing that it's properly formatted. The other thing I want to do, because I want to show you the dynamic changes, I'm going to, instead of 1 minute in between reads, whoops, I got to do this with a key. I'm going to put 0.1, and I hate when that does that. Go here, see if we can get this 0.1. Okay, so I'm just going to do, every, 1/10 of a minute read. So we're going to we'll see some changes to the information being stored, right? Those are the only two things I need to make changes on this program. Otherwise, they've given us a program that's fully functional. does everything it's supposed to do. Okay, but to save those changes out of Nano, we hit Control O and then enter. You can see down here it's asking us, is this the file you want to write? Yes, it is. We're going to hit enter and then Control X will exit out of Nano. Okay, so we downloaded a file from initial state called pyhealth.py, and we made a couple modifications to it just to give them our access tokens so that we can collect data off of our machine to our account. Okay, I'm going to go back over here, bring that up, and then to run this program, let's go back over here. So this is the program I copied. I'm going to hit back arrow to get back to the instructions. I've already run you through these instructions. So to run this program, it's simply going to be Python pyhealth. Right mouse click and then enter. Right. And this is an ongoing program. There's no end to this program until I tell it to end. Which means it won't come back. So this terminal won't come back to a prompt. It shouldn't come back to a prompt. I'm going to come back over here to my initial state and I'm going to refresh. And over here, we should see, I'm hoping to see, yeah, Pi3 performance right here. So if I click on that, that program that I just ran gave us all of this crazy information. Right. So to me, this is pretty cool stuff. Right here, you can see here's the CPU utilization on CPU 0, CPU 1, 2, and 3. Okay. Over here, we've got memory totals, memory available, memory used, percentage, memory used megabytes and free. I've got my network stuff over here. Right, so network receiving errors. So I'm looking at those errors, packets dropped. I'm not picking up any of those things, which is nice. Here's my disk totals. If I were to, let's see if we can make some noise on this. Let's get bring up a browser real fast. So what I'm hoping to see with this is the like where some of our memory usage should go up. We should have some network connectivity things going on. So, and as I, so those are this, I got some, Western, we got my school, right? So I'm just using the browser real quick. We could probably, let's do a diagnostics real quick. So that should be some processor utilization. So this is going to test the SD card. So I'm going to set this off to the sides just so we can kind of see, right? You can see this dynamic changing of everything here. Right, so 86% utilization on my processors right this second, doing a diagnostic, running a bunch of video in the back, or a bunch of web pages in the background. But this one's not really useful to me. Like, I wonder if I went to edit the tile, let's change this to, instead of a line graph, let's change it to like a gauge. Yeah, let's do that. That looks better, right? So, right, so now I got this dynamic, right? My CPUs, I can change these tiles to be really fun and interactive, right? And I'm hoping you can kind of see that, from this, from a sysadmin standpoint, I kind of, how could I make this, a CIS or a CS kind of a thing? Well, from a sysadmin standpoint, I could actually use this kind of thing to monitor my servers, like the key ingredients on my servers. And at some point, probably add in alarms based on that without, buying expensive software or getting tied into contracts or anything like that. We've just done this on our own. And right now we're doing it with a Raspberry Pi, and you can kind of see that I can adjust how these things look and feel, right? Are there any questions at this point? has anybody been able to go along with me? Like, so it's hard to tell if there's people that are, if you were able to do anything, or just watching, which just watching is fine, and coming back and watching the recording later and trying this out is also fine. Nice. Yeah, this is pretty, there's some pretty cool stuff you can do um, with this. I thought this would be just, I mean, it's like we didn't need to have any extra parts. You just have a Raspberry Pi and we can move along with it. So if you've ever, a lot of you have been in my workshops before, I'm never done early, which is right. And we're at 35 minutes. I'm like, wait a second. What happened? So, however, because we're using that same,
You have an hour, Carrie.
I know I do. That's why I'm like, wait a second. I have something else. I have some extra stuff. So on this thing, also, the other thing that's cool about this is, the last piece of this from the tutorial standpoint is you can unlock the layout, and we can start to move tiles around, right? So I wanted to, let's see if I wanted to have, say maybe all my CPU stuff all together over here, right? So this makes this, I don't know, this thing is just kind of fun. You can readjust everything. So then I can say I got all my CPUs over here. I saw there was a CPU temperature gauge. I don't know what kind of gauge would look good on this one. So there's a bar pi. So summary is just going to tell me the temperature. That's probably fine, actually, right? I really don't need to see a chart. But for this one, we'll just do that, right? So then we can also, whoops, I can make it smaller, right? So then for this particular dashboard, right, you can customize your dashboard. I've got my CPU utilization and my CPU temperature, which 133 seems like it's really freaking hot. Especially because it's open air, but all right. And then you can see, like, if you wanted to kind of tie we got memory things, there's 3 memory things there. There's networking, here's disk usage, CPU usage. So there's another CPU, that's a total, like, so these are individuals, and then I've got a total that we can kind of adjust. And then I could put my memory items together, and you can put your network items together, and then you adjust them to to be the most useful, right? The most useful to you. And some of these things, like the outgoing package drops, like we can make these little tiny and put them out of the way. You can see we haven't had any kind of issues with packet loss at all, which is nice. To not have those issues, which is good. All right. So this isn't going to be pretty. This part isn't pretty, but as you could spend time to get it pretty and adjust it the way you want to. So you have these dashboards. You could create dashboards and only pick up key ingredients, and you can pick them up on different machines and then create dashboards where they all kind of consolidate and work together. As an option, right? So pretty cool stuff. Again, what's nice about this, and I always look at this from a student's perspective, right? So I'm creating a dashboard of system, and they didn't need to buy a server to do this. They didn't need to have $500 or $600 laptop to do this. We did this all, on this $100 worth of equipment, which is a big key for me. Like our school. In Albuquerque in New Mexico, we have a pretty high rate of poverty and a high rate of minority. So I'm always looking for how can I make sure that these things are accessible to everybody. all of my students, right? And if they have this device, can I do different things in different places to utilize it and to give them opportunities to engage with the material. Okay. So we're going to go off scripts, right? Because I still got 20 minutes. So we're gonna head off scripts, and we're gonna head back to, if you don't mind. I mean, if I don't want to be done yet. So let's just keep trucking. On this page here, we had this. Let me go. I think this one I can get there from here. What I want to do. Oh no. There is another exercise that we can do. I'm trying to get back to their web page. I don't need. There's another one that can monitor a process, right? So again, we're thinking from a sysadmin standpoint. You've got some key processes running on your servers or on a device, and you want to maintain those, and you want to make sure that they're running, and you can have this information on a dashboard and trigger things. So right here, monitor your Pi processes and IP address. So we're going to kind of cruise through this one real fast. So what we're hoping to do here is, and we're not going to show a bunch of these. I'll grab, we have that Pi Health running. So we'll go and look at that one and show, and then we'll kill it and we'll show what happens with that. But it's going to give me, the process and is it running or not running, and then the IP address that it's coming from, which is going to be useful information for a sysadmin that's doing monitoring on their network. All right. So we don't need to register. We've already registered. And we've already done the ISS streamer, and we've already done the AutoMagic, and we've already tested to make sure, and we've already looked at our keys. So this whole first page is basically a repeat. So I'm not going to worry about that too much. What we are going to be worried about now is, how do we monitor a process? Okay, so so maybe I can do this way. I don't want to use this one because it's running. So let's do, let's fire up another connection to my Raspberry. Okay. So I've got two different terminal sessions running. So this is the terminal session that is running the Pi Health process in the background. And this is the new session that I just created. I'm connecting to my Pi again. All right, so I've reconnected. And we're going to run this command called PS, which is going to show me that I've got a couple of services running Bash and PS is running, and then they both have these PIDs, which is the process ID number. That's the key ingredients for what we're going to look for. There's also another command which will give us a lot more information and allow us to see the process that we are looking for, right? So this is actually grepping anything that has PY in it. So we can see right here. I know it's hard to read. It's hard for me to read. Right there, we have a process pihealth.py, and the process ID on that one should be 17, right? 1740 is the process ID. Okay, so that's the number that we're going to key off of. We're going to create a monitor that watches process 1740. Okay. That's the plan. So they're going to do the same process that they did before. They've got a program that they've created for us. Okay. And this will be using PS Util, the software that we installed earlier to grab information for our other dashboard that we created. So I'm going to grab this file. copy that over here, and I'm going to go back here. So they want us to call this monitor underscore process pi. So nano monitor underscore process dot py. I should spell process correctly. That would be good. All right, looks good. That's going to create a blank page, and I'm going to right mouse click, and it should put the program that I copied into place here. Okay, we need the access key. Right? So we're going to need the access key here from our system. So I'm going to come back over here to my settings. I'm going to grab this access key again. Oh, I always forget to do that. I got to use the keys. So I'm using, so SSH. Both of my computers are on a wired network. My network is set up where I can transverse from wire to wireless. So I could have left the Pi on wireless as well to do that. So I'm using, I think there's lots of questions about that. So I'm using PuTTY using SSH to connect to the Raspberry Pi, which I have off to the right. If you were on the Raspberry Pi, you would be doing this on the Raspberry Pi. I also have VNC running here so that you can see this is what the Raspberry Pi looks like currently. So we did a SD card test. We were just kind of pushing some data on our, so if I close all these down, right? So this is using VNC to connect to the Raspberry Pi, but the blue screen here is if you were sitting in front of a Raspberry Pi connected to a monitor, this is what you would see. This piece, this PuTTY piece that I have here, you would just run it in the terminal if you wanted to do it that way. I'm connecting from my PC, which is, I like to have my students do it this way so they can run without a monitor on the Raspberry Pi. Plus, they get the skill set of remotely connecting to machines with SSH, with VNC or some type of like an RDP type of a client to connect to their systems. Okay, does that help? Did I answer the questions? So I right mouse clicked and put my code in, and then I put my quote back where it needed to be. And then right here, process, place the name of your process here. So we're just going to put the name of our process. This is pihealth.py. So this is just the process that we're going to follow. And there should have been, where there's no other thing, I don't think. Let's double check. I think that's all we need to do with that piece, but we're going to go double check and make sure. Okay. So what we're going to do is we're placing our access token so that the program will connect to initial state, and then we're going to just name it so we know which one we're looking at. Okay, and then the next thing, I don't want to leave 15 minutes between the reads, so I'm going to make it like a 0.5 because otherwise, right, we would never see the end result of this. Oh, my numlock is not on. I'm like, what is going on? Did I just delete it? I think I did. Awesome. Good job, Carrie. So, minutes between. Oh, I moved this. What happened?
You just need to hit enter after that. Yeah.
I just sound like, what happened there? Okay, so 0.5 is all I need. 0.5. All right. Cool. That's all. So every half a minute it's going to check for us. 15 minutes is probably fine on a normal system unless you have a real critical service that's running. So those are the only changes I'm going to make. Access key, the Pi health, and then the minutes between the reads. Okay, so Control O to write this out to monitor underscore process.py, and Control X to exit, right? and then I'm just in an up arrow, and I'm going to change the word nano to Python. And then I want it to monitor the PID that we looked at earlier, and the PID that we looked at earlier was the 1740 right there. So I'm going to put in the number 1740 there. Okay. And I'm going to hit enter. So this should actually have started a process that's monitoring that process, right? So we have a program monitoring a process to see if that process is running. And hopefully we get a new, so we got processes, right? So this is new. And then you can see here, PyHealth, my IP address, that's the machine that I've got. It's actually the local area network machine, IP address. And you can see that the process is running, right? Pretty cool. All right, so imagine if you had 3 or 4 different processes, you could have a dashboard that collected all the different processes, and you can keep an eye on them. Now, to see what would happen, so here's the PyHealth, right? And if I Control C, that should have killed the process, the PyHealth process. And what we're looking for here is for this to go, there it goes, into a state of exited. So we exited out of the process, which also exited us out of the monitoring process or the monitoring program, okay? So just again, like this, this was a bonus extra time kind of thing. What we did is like, now if we come back over here, take a look at this. So the process isn't running any longer, right? So you can see this one, this is the trigger happy Python 3, and then this is the grep command with the Py, but there's no, the PyHealth is not running any longer, okay? If I go ahead and bring up PyHealth again, okay? So PyHealth is running. If I go back to initial state and I look at my performance here, we should get some variations to show that, yes, it is actually running. So you can see that my program is running. Whoa, it just killed up to zeros. Oh, I'm not doing anything on the server. I'm like, what's going on? So if I go here and we open up something real quick, I'm going to move that off to the side. We don't need to see that, but what I'm trying to do is just get some spikes on the processor. There we go, spikes on the processor, so we can tell that it's running. Okay, my PyHealth is running. Okay. Now, so one of the gotchas on this, and this is where we're not going to have time to do this, is if I were to run the Python monitor process 1740, okay, I'm going to hit enter, and it's going to go, the process doesn't exist. And I'm like, well, that's what my process was, right? You can see it right here. Okay. However, because we killed it and we restarted it, it has a new process ID. Okay. So it's got now it's 3162 instead of 1740. Okay. So then we would have to change this to 3162 instead of 1740. And that should now properly monitor that service. Okay. I'm doing it manually. The instructions here, you can see that it's running now. The instructions actually, which time-wise we're not going to have time for, but they will watch you through how to launch a monitored process and how to modify the numbers automatically. And then if there's a reboot or you have to start it over, how you can automatically have the program find the process ID for you, right? So this one, once you've gone through all of the steps of the system or of the tutorial, you can see there's a bunch over here. You can actually, it will automatically launch the monitoring process on the boot of the machine. And then if a process goes offline, it will watch for it to come back online using a different process ID number, right? So again, I think all I really wanted to kind of share today was just this really, this was pretty straightforward. I mean, the instructions, if you read through the instructions, I've kind of skipped over those parts. I just wanted to show you that, there's lots of these little projects like this where, hey, let's monitor like our email service. So let's monitor our DNS, or let's so, and you can build your own those services. You can build your own dashboards. In this case, like we're monitoring all the different kind of performance monitors of this. Lots of really cool stuff that you can monitor from a, again, system standpoint. I didn't need to have anything extra for that. Okay. And then when you want to get, really fun, you can come back to this page here where, like, here's temperature monitors, beer and wine fridge, maybe not a school thing, but right, maybe at home. I think students would have fun with this one: weight tracking, text messaging, scale with a sense of humor, right? So they're connecting a scale to the Raspberry Pi and it's giving you feedback. And there's lots of these, there's 22 tutorials specifically here on Raspberry Pi, all kinds of really fun things. A lot of it was temperature. They saw some temperature things. I saw one where they're connecting weather, so outside weather, and then you're doing sensors in the house, so then you can compare inside weather and outside weather, and you can actually have that go to a phone app that's part of the system, so they can create their own app where they can start to control all kinds of other cool things. I'm interested in initial state. This is one of my first times playing with it, but this idea of building like these dashboards, right? These web-based dashboards where we have things that it collects, and you can see there's all kinds of fun things that you can put together. This one, like, it's grabbing information from an online weather service, but you can do that. And I have students that create magic mirrors all the time, but this would be another one of those magic mirror kind of things where you've got you can maybe put your Google Calendar up in here and have the weather and the forecast, and maybe pull some traffic data, things like that. That'll be really fun, and it's all, again, controlled on this little $35 computer that we strap to use monitors most of the time. So but that's it. That's what I just wanted to kind of share, some fun things that you can do and play with, and kind of walk you through a couple of those real quick. Does anybody have any questions? Did I miss any questions? I probably did. All right. Yeah, and if you want ideas on things that you can do with your Raspberry Pis, from the presentation earlier, there's a ton of good stuff, right? If you wanted to do like Pi-hole, that seems to be a popular one. That's an ad blocker. It's a network ad blocker. It'll block everything, all the ads that you get on your PC. It'll block those as it comes into the network. I don't know what the normal temp. What was mine? Mine was running 130 something, right? 123. That seems about right? That's a kind of a normal temperature. What's that in Celsius? That's like in the 60s, right? 70s. That's about normal, I would think. 160, 120. Yeah, so I've got this one's a Pi 3. I think the Pi 4s run a little bit hotter. So a lot of times we add fans to those. And to put those, to keep them cool and usable. But yeah, so this is, again, this is only one place where there's information. I just thought this one would be a fun one to play with. So cool.
So you're only down to the last couple of minutes here, Kerry.
I survived. I did it. I got done on time.
Yeah, you're awesome. We
and
saved
it worked.
The best for last too. So,
and everything.
Thank you so much.
No, great. My pleasure. My pleasure.
And everybody who hung in there too for the end, that's great too. It was really a unusual but great time. I was so impressed with the platform, and hopefully let us know what you thought about it if you get a chance.
Frank, hey Frank.
It was great. We had 349 attendees all together.
That's awesome.
Yeah,
loved it.
So
very
great.
Cool.
Well, thanks everybody. Have a great weekend.
Yes.
And, everything's going to be still available. You can go look at the keynotes. You can still see all the sessions, those that you missed, which is something we always kind of wanted to do with face-to-face and could never really do that. You had to pick and choose. So,
right.
Do I need to say safe travels home? right? Don't have to say that.
Nope, we're already there.
We're there, and but be safe anyway. And 2021 is going to be a good year. I have this feeling. So, and
I hope.
I think we'll be back together next January,
Yes.
2022.
And we'll do this all in person.
Yeah.
That'll be fun. All right.
All right. Thanks all.
Enjoy. I'm going to go ahead and stop my share and we will end the meeting. Actually, I think Laura can do that.
Yep, I will take care of that. Thank you so much, Carrie. That was amazing.
Hope you had fun.
I have a pie, I have a pie sitting here behind me, and I keep thinking, I got to get to that. I got to get to that.
What can I do with this?
And there goes my whole weekend, Carrie. Thanks a lot.
I'm just going to say for you, pineapple pie.
Oh, okay. Got it. Got it. Oh, that is awesome. Yeah, there goes my whole weekend, Carrie.
Yeah, you're welcome.
Okay, cool.
I tell people I'm a drug pusher. I just want you to try a little. All right?
Get
just
off
try
from
a
a
little.
playground. Get off from a playground. That's awesome.
Just don't let him talk to you about Humble Bundle. That'll.
Oh my gosh. They just take my money every other day or so.
I'm making notes.
Humble Bundles. Got some good stuff.
Oh,
Good stuff.
What is
All
that
right.
website called? Thisiswhyimbroke.com, I think it is.
Oh my gosh, really?
I think
I'm
it's
gonna
called
check that out now.
thisiswhyimbroke.com. Yeah. You can actually buy a car that can turn into a submarine there.
Nice.
Yes.
Wow.
Great.
Let's do it.
choice.
All right. And then I had to go, my beach scene's a little different than everybody else's.
I love it.
I love that too. Yeah.
That is nice.
Yeah.
Yeah, this is Karen. I loved your beach scene, and then your background for your slides with the what's her faces on there. Those were great.
Yeah. I don't know. I struggled with the template that came. I'm like, what? I'm just going to go as close as I can.
Hey, the beach. Put a hat on it. Yeah.
All right. We're good.
Whatever works. Okay.
Oh,
So
and thank you, Laura, too, for all your
Yes,
hard work.
Laura,
I know,
thank you.
It was pretty amazing. No one really realizes the amount of time you put into this, and so
it's
thank
a
you
lot
for
of
that.
fun. Very interactive group. Like I said, wow, so different
Super.
Yeah,
in other events. Very funny
Yes.
group.
we're a
Great.
community.
Great humor. Yeah.
All right.
Excellent.
Take care,
Enjoy.
everybody.
Have a great
Bye, everybody.
weekend.
All right. Take care. Bye-bye.
Bye.